Week 7, Stars, Planets, and Galaxies. Tour of the Universe. This issue of Science Studies Weekly Endeavor is about the universe and all the stuff in it. When you look up at the sky on a clear night, you see thousands of points of light, and every one of them is a star. Is that the universe? Well, it's a tiny part of it. Most of the universe is so far away from us we can't see it. It's made up of stars, galaxies, meteors, asteroids, comets, and quasars, and between all of those huge objects is lots and lots of empty space. Let's try to take a trip through space and get a better idea of how big our universe is. Let's begin our tour by flying out to the sun. Our sun is a star, just like each of those sparkling dots in the night sky. The sun is 93 million miles away from our Earth. Two really big good trivia facts there. Our sun is a star, 93 million miles away. That's the distance. And it's so big that 1 million Earths could fit inside it. The sun provides the energy needed for all life on Earth. If we could fly past our sun, we would see other stars in the Milky Way galaxy. A galaxy is a large cluster of stars. Scientists believe there are more than 100 billion stars in the Milky Way. Some of those stars are bigger than our sun and some are smaller, but they are all far bigger than our Earth. Our Milky Way galaxy is huge, but scientists believe there are more than a billion galaxies. Each one has about 100 billion stars. Now we're starting to see that the universe is so big we can't even really imagine it. This week we'll look at galaxies, how stars form, and how astronomers study them. And don't worry, we've also got some other objects to talk about. Meteors, asteroids, comets, and quasars. There are lots of objects in the universe, so it's going to be a busy trip. Buckle into the spaceship and let's go. Stars, planets, galaxies, and more. What's the big idea of this issue? Well, it's the universe, and you can't get any bigger than that. Everything about it is big. Let's start with those twinkling stars you see covering the night sky. Stars are huge spheres of burning, glowing gas. They produce light and energy by a process called nuclear fusion. This is when atoms of lighter elements are forced to merge into heavier elements. Most stars are made up mostly of hydrogen and helium. Those are two important gases. In nuclear fusion, two atoms of hydrogen with one proton in the nucleus, center of the atom, slam together so hard they change into helium with two protons in the nucleus. Protons are positive, if you remember. Nuclear fusion gives off a tremendous amount of energy, which is why stars burn and glow. Stars form in a place called a nebula. It's sort of a nursery for baby stars. Nebulas are huge areas of gas. Pictures of nebulas look like colorful clouds. Stars form when gravity pulls the dust and gases in these clouds together into a clump. As the clump grows, so does its gravitational pull, which brings in more and more dust and gas. Eventually, the clump begins to burn, creating a protostar, a star that's just beginning to form. Under intense pressure, nuclear fusion begins, and the star begins its adult phase, called the main sequence. This phase lasts an average of 10 billion years. At first, the star is small and bluish-white. Over time, the star grows and becomes yellow. Finally, when the star has used up most of the hydrogen, it is large and red. These older stars are called red giants. Red giants are very hot in their core, so hot that they create heavier elements like carbon, nitrogen, iron, and oxygen. Finally, when there is no more hydrogen to fuse, the star explodes much of this material into space and collapses into itself. This material goes on to form new stars, so stars recycle. And crazy fact, because it takes light a while to get from one place to another, we can actually see stars that have already burned out because it's light. The light from the star is still traveling through the sky to our eyeballs after it's already collapsed into itself. Science is crazy cool. Our star, the sun, is about halfway through its life. It is a medium-sized yellow star that's been around for about 4.6 billion years. Astronomers think Earth and the other planets formed from the space dust left around the newborn star called the sun. Like the sun, planets form when dust clumps together to form hard rock material. As the clump of rock grows, its gravity pulls more particles and space debris into it. Over billions of years, the planet becomes a sphere that orbits the sun. Planets that are rocky are called terrestrial planets. These are the first 4 planets in the solar system: Mercury, Venus, Earth, and Mars. Those are our terrestrial planets. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are mostly gas. They're called the gas giants. Even though they're made of gas, they aren't stars because they aren't made of mostly hydrogen and helium, and they don't create their own energy by nuclear fusion. Because they're made of gas, these planets are called gas giants, and you probably guessed they are much larger than the terrestrial planets. Since we're talking about big things, let's look at galaxies. A galaxy is an immense collection of stars, dust, and gas. Galaxies contain billions, sometimes trillions of stars. Now that's big. Scientists classify galaxies by their shape. Some are spirals and some are elliptical, shaped like an egg. Others have no distinct shape, so they are called irregular galaxies. We live in a spiral galaxy called the Milky Way. Our sun is located on one of the arms that swirls out from the center of the galaxy. Yes, a galaxy is big, but the universe is even bigger. It's made up of billions of galaxies. So the next time you see a big car, or you think you have a big problem, think about how big the universe is. Astronomy is the study of the stars in space, and there are lots of things flying and floating around out there. Sometimes it's easy to get confused about what all those objects are. Well, don't worry. Here's a quick guide. Meteors. Meteors are pieces of rock or minerals that are flying through space that are commonly called shooting stars. When these rocks travel through our atmosphere, there is friction, which causes heat, and the meteors burn. We see them flying through our skies. Meteors stay in space, and they usually burn out. There are also very large meteors that don't burn out. Instead, they orbit the sun. These are called meteoroids, and when a meteor falls to Earth, it's called a meteorite. It's very rare for a meteorite to fall to Earth. So the next time you see a quote-unquote shooting star, you can inform someone, that's actually a meteor, and they will think you were just an awesome scientist. I didn't get to learn that fact till high school, guys, so you're pretty privileged. Keep learning. Quasars. A quasar is an extremely bright object located in the farthest known areas of the universe. Quasars are a big mystery. Scientists do not believe that quasars are the same as stars. In fact, quasars are much brighter and create much more energy. A quasar can give off as much energy as 1 trillion suns. Quasars are an interesting puzzle for astronomers who have not yet figured out how quasars make all that energy. So if any of you need like a career idea, that's a problem you can solve, learn more about. Asteroids. Asteroids are much bigger than meteoroids. They are huge chunks of rock, sometimes miles across. They revolve around the sun, but they are too small and unevenly shaped to be planets. There's a belt of thousands of asteroids between Mars and Jupiter. Do you guys remember that from I Have Who Has? It's called the Kuiper Belt. Is this asteroid belt the remains of an exploded planet? Scientists don't know for sure. Comets. Comets are balls of gas and dust that orbit the sun. As they get closer to the sun, they burn and form a head and a tail. Comets are often named after the astronomers who discovered them. 2 very famous comets are Halley's Comet and the Halley-Bopp Comet. It's like top, but without the T. Oh, man. In the spotlight, Harlow Shapley, the edge of the galaxy. Did you know that up until about 100 years ago, many scientists believed our sun was the center of the universe? They knew that our sun was located in a swirling disc-shaped galaxy called the Milky Way, but they thought they were in the center of the disc shape. It was an American astronomer named Harlow Shapley who first questioned this idea. He observed, measured, and calculated the distances of the stars he could see in his telescope. Shapley realized that our sun was not in the center of the Milky Way galaxy. It was located near the edge. In 1920, Shapley presented his findings to other scientists. Soon, astronomers realized that our star, the sun, is not the center of the universe at all. In Shapley's time, a galaxy was the biggest thing astronomers could imagine. Their telescopes were not powerful enough to see stars beyond the Milky Way, so they thought the Milky Way galaxy was the universe. Outside it, they thought there was nothing but empty space. In fact, that's why we still talk about outer space. It is the space beyond the stars that we used to think was empty. Since then, scientists have developed more powerful telescopes. Some of those telescopes have been placed onto spacecraft and sent them into space to take pictures of the universe to send back to Earth. Those pictures show us a much larger universe than we ever believed. It turns out the Milky Way galaxy is only one of billions of galaxies in the universe. This week's question: what exactly is a light year? A light year is not a unit of time. It's actually a unit of distance, a very long distance. A light year is the distance that can travel in 1 year. So light year is the distance light can travel in a year. And since light is the fastest thing scientists know about, it can travel very far in 1 year. Actually, light travels about 186,000 miles per second. Boom, that fast. That is fast, people. 186,000 miles in 1 second. Okay, that's also an awesome trivia thing to memorize. Why don't astronomers use miles or kilometers to describe how far the stars and planets are? Well, it's because the numbers would just be too big. It would be like talking about the distance around the Earth, or the Earth's circumference, in inches. So astronomers decided to use the fastest thing they knew about, light, to describe the biggest thing they knew about, the universe. So just how far is a light year in miles? Well, it's almost 6 trillion miles. After the sun, the closest star to Earth is called Alpha Centauri, and it's 4.37 light years away. If you get out your calculator, you might be able to calculate how far away it is in miles. If you came up with 26.22 trillion miles, you'd be correct. Another way to look at light years is how long the light from stars takes to reach us here on Earth. For instance, when we look up at the twinkling star named Alpha Centauri, the light we see today left Alpha Centauri 4.37 years ago and is just getting to us now. Honestly, guys, I was thinking it took... Oh, no, I was thinking like minutes, actually. I think it's like 8 minutes is how far it takes a certain distance, though. So, yeah, so that was a lot longer than I was thinking. And just in case you're wondering, our sun is pretty close to us, 93 million miles, nowhere near a light year. The sunlight we see, there we go. The sunlight we see and felt left the sun just 8 minutes ago. So my 8-minute memorization is from how long it takes the sun to get from itself to the Earth. Fun fact. Clearly Mrs. Top needed to brush up on some of her universe facts. We're not gonna do the mini lab, but I'll read to you about a spectroscope just so you can learn about it. If scientists can't get close to stars, how do they know what they're made of? They use a tool called a spectroscope. When you look at a light through a spectroscope, it breaks the light into wavelengths like a prism does, and every element has its own unique spectra, sort of like we all have unique fingerprints. But other types of light break up into colors and show what elements make them up. So when scientists look at a star through a spectroscope, the color pattern tells them what the elements are in the light they're seeing. This is how they know that stars are mostly made of what two gases? I hope you remember because I said it like 4 times. Hydrogen and helium. And if you are interested about some NASA stuff, there's information down here. And it talks about different math and science classes you would take if you want to go into like a NASA type program. And there is a kids NASA website as well. So check it out if you'd like.